Hi everyone, so today I'm going to do some problem of Newton-Raphson method on programming part. So basically on the previous one I finished bisection method. So before that uh let's look directly at some algorithm related to this. So first step is nothing but just starting the program, and just here we need to guess one input initial guesses, so that on the case of bisection we need to guess two. There is not that type. We just need to guess one. So after that we need to find first derivative of that function, and there is one formula where xi is equals x0 minus fx0 upon f tax. X0 means uh, f to whatever value we are going with, we should keep that, and the formula is x naught minus f x naught upon, and on the there is derivative, first derivative. So this is same of absolute derivative error, which is bar of x1 minus x0 upon x1, and just we need to be clear here, so that if the error we calculated is bigger than the given error or tolerance error, we should go to step T. That means we should repeat all this step again and again. So if there is error is smaller, we should just end the program, just terminate the program. Okay. So let's try to do this code. There is mathematical code. So let's do program. Okay. So for a minute, I just want to check that on my phone whether it's working or not. It will be easy. Okay, wait for a minute. Oh, I think it's not working here. Oh, it's working. Okay. Okay, so let's move after programming part. Let's start it. Okay, so let's open my terminal. I use VS Code. So let's give this method Newton Raphson method, Newton Raphson dot C. I'm coding on C. Okay, so let's start with header file. So that will be, so that you guys can see, include stdio dot ads on your dot ads. Since I'm using the math functions, so let's use math functions so that it will be easier for us to remember, right? Math dot ads. Okay, so let's define a function. Okay, let's define function for the for now. Let's give function fx. That name will be fx. And let's, oh, I forget to write define. Let define function fx. That's called fx. Let's give here some specific name. Okay, so that will be, for my case I will use coefficient. Okay, let's use a3 coefficient. That will be multiplied with x. That will be 3 times x, 3 times x plus, let's give a2. That will be 2 times x, 2 times x. Okay, and let's give a3x cube plus a2x squared plus a1x, a1 multiply x plus, at last just keep a0. Okay, nothing more x. So this is nothing but we're just defining function. And in Newton-Raphson method, as I showed you already, we should calculate second derivative, right? For that we should calculate, sorry for that stuff, we should calculate the second derivative, right? So I'm just we should define second derivative also, f dx. Let's keep here. So the derivative of a3x cube will be 3 multiply a3 multiply x squared. That means x into x, right? Yes, it's correct. So let's do plus, and x squared derivative will be 2x, will be x square derivative will be 2x. 2x means a coefficient into x, right? It's correct. Plus the final will be just a1, right? It's a1. This is nothing but a derivative, given function. Okay, derivative of given function. Okay, so let's start our program, right? So before starting a program, I want to declare that this variable, right? We are using this coefficient. Okay, let's declare coefficient here. That will be how many coefficient we are using? Four. So that there is A0, A1, A2, A2, A3, and A4. Okay. So you are using this. Okay, let's step to the program. In the main, okay, we are in bed. So for that we need to use some variables, right? So let's declare first we need to guess initial guess, that is x naught. So that will be x will be increased for a specific time. So let's create a function that we need. So for now I will add later. So let's create just x1. X1 we need to put value of x naught. We need to, and we also put derivative of x dx naught, since we need to calculate derivative. And we need to give some error precision and we also calculate absolute relative error. After finishing that, let's say user to input something called enter coefficient. Okay, user will enter the coefficient coefficient, yes, enter the coefficient like say A2, A3, A2, A1, A0. User will enter the coefficient. Let's scan app and put this on percentage f. How many? 4 percentage f, 4 percentage f, percentage f, percentage f. That will go to the variable of a3, right? Yeah, a3. That will go to a3. That will go to a2. That will go to a1. That will go to a0, right? And that will go to a0. Okay, that's not fancy. We just create the function, create a input so that user will input the something called user will input the coefficient of variation. So it's set reload required. Okay, let's reload for a second. Now it's work fine. So for now we just take the input in the main program bin. So let's also input initial guess, right? So that user will, since in our algorithm user is initial guessing, user we need this x0 from user. So let's enter the initial guesses, initial guesses, so that user will initial guesses scanf, and let's give this, store this value on x0. Okay, I think this will be fine. Oh, that will be okay. So after this, let's say to enter the tolerance error. Okay, tolerance error, or let's just say error, precise error. Let's say precise error. Sorry, user will use scanf, that it also come into the flow, and after that we need to store this value on e. Okay, we need to store this value. Okay, input part is finished. Let's dive into the program. Oh, it's scan is playing. Okay, so we just finished the inputting part. Nothing fancy, just asking for coefficient, asking for initial guess, and asking for error. Okay, give let's focus here. It's a more part so that we can go through it. So we don't know our process, right? So let's use while loop, since we don't know for how much we need to go. While one, okay, while one. If user input one, so the process will be one. So that here we use let xi equals like we are directly giving your value one. Hmm. So first of all, we need to put the value, the user inputted this value here, right? We need to put this value into this function. Let's put that value on that function, okay? So to put value on that function, we need to put value on f x naught. We need to put this value on here by using our function f. by using our function f and x naught, because we are inputting this x naught value, this initial guesses on this expression on this function. Okay, so we just put this, and also let's put derivative also. F dx naught equals fd and x naught. So just we put this initial guesses on this function. Okay, we put use this initial guesses on this function, mm, in this variable which is declared here, so that the function will calculate its function and derivative. Okay, after that we need to calculate. We just calculate for one. We are doing for one. Okay, not fancy. Just we are calculating one. I mean, just we put here one x I. Just we put here. We are calculating for first order linear polynomial equation. Okay, so while one. Okay, so let's calculate the error. Right, error is so easy to calculate error. Error means what? X1 minus x naught, x1 minus x naught upon x1. Okay, if you need to see, look here, there is formula x1 minus x naught upon x1. X1. Okay, if FABS FABS, if FABS means that checking. This means if there is negative value, it will be automatically be positive, since in their function there is something called, oh, what is this called in mathematics? I just forget. So this is called facts. This is a function in C program that will convert that negative into positive. Since in absolute relative error, no matter if the answer comes negative or positive, we just change the sign. If it comes to positive, is it okay? And if it comes to negative, we just change sign for negative to positive. So let's use here. If facts, we need to calculate ER is less than E. So if our error is less than E, oh, it's our answer is automatically correct, right? If answer is less than E, we just need to go to step 7. That means we terminate. That means we need to print the root. Root is percentage F. And where is root stored? X1 or X1? I just confused. Okay, let's check here. I think root is stored on X1. Okay, root is stored on X1. Okay, sorry. Okay, that's right. Perfect. Let's use break. Since we are not ending this if, we are again continuing here. So if it is less than error, the answer is automatically that. If not, we need to give x0 is x1. We need to give x0 new value, that is x1. So so I just got confused here. We put x1 value here. And I don't know how x1 is calculated. Okay, just wait for a minute. Oh, here is we declaring x1. Yeah, x1. So initially, what's the value of x1 here? I think there might be mistake. Yeah, there is mistake. Yeah. We just forget one function here that I just found. Okay, we directly give x1 on the error, but we don't have value of x1, so we need to use one formula. You know that formula is too easy. I just show you. We need to input this. We forget to input this formula there. Okay, so this is x naught minus fx naught upon f plus x naught. In our case that will be x naught minus, let's put upon, no, let's not put fx naught, fx naught upon f fd x naught. Okay, fd x naught. Okay, that's correct. Now we are on our track. So let's give error so that it will go like 50 step. Okay, no matter 50, let's put 40 step. If you go to 40 step, it's bad. It's like something called it's not. So before using int I, we should use int I. Oh, it doesn't need here. Okay, we need to declare this here. Right. Now it's right. It's almost right. Okay. This bright, let's close program. I hope this program will run correctly. GTC gets. I think there is not mistake, no problem. We are living in the era of ChatGPT so that we can ask there. GCC Newton Raphson.c. No error. Okay. What's file name? Sorry. What's our file name? A.exe, but there is error, I think. Okay, so let's give. I want to give 1, 0, 5, minus 3. I want to give initial guess 2. I want to give either 0.05. Here is 0.04. It's almost correct. Okay, let's give something example. Let's solve this problem. Okay, I created the function. There is just x naught. So let's clear this and just run once again our program. Okay, so there is no our x3, right? X3 is no. Let's keep 0 and 1 and 4 and minus 9. If you don't know what I'm doing, so we declare your x cube, right? We give x cube plus x square plus x plus something like c. So there is no x cube, so we just give 0. And instead of x square, the value is 1. This is constant, right? So here before there is nothing but 1. So there is 4 and there is minus 9. Okay, I just input there, and the error is 0.1. Error is 0.1, and the initial case is 4. Initial case is 4. Here is 0 point. I forgot what is it, sir. 0 0.1, 0 0.1. Root is 1.605659. Okay, let's check. Is this correct or not? Our answer is correct or not? 1.605. Oh, our answer is correct. So it's it's not for today. So okay, thank you. I wanna end our stream.